Hello everyone, welcome to CP Geeks. Today we'll be solving running sum of 1D array. Let's go through a problem statement. Given an array nums, we define running sum of an array as running sum I equal to sum of nums 0 to nums I. Sum I, we can also write this running sum I, running sum I is defined as sum of all the elements from num 0 num 0. We can also write something like this one, num 0 plus nums 1 plus nums 2 plus nums I. So we can solve this problem multiple ways. So one way is to solve this problem is using brute force. So for each value we start from 0 and sum till I plus I. So assume we are at index 2. Let's type the code, then we can understand. So this is like default brute force solution. Okay, so let's also create a running sum array. So running sum, initialize all value to 0 and size will be same as num array. Running sum I, so we'll create local variable sum 0 and for in j is 0 j less or equal to I j plus plus and sum plus equal to nums j. And after once this loop is over, we will assign running sum I to this sum variable. So in this one what I'm doing, let's go through the first example. Start from here. So initially I declare like sum array with 0 comma 0 comma 0 and 0. So here then for the 0th index we'll start a loop. So for I is 0 and we'll start a loop from 0 to 0. So there will be only one entry 0 to 0. There will be only one entry. So for that one we'll have sum will be 1 and then this value will be 1, and for I equal to 1 we will be taking some of these two values. So sum value will be, also remove this line, sum will be 3 and here sum will be 6 because we will be taking sum of all three these two values. So this will be 3, this will be 3 and this will be 6, and the last sum will be sum of all the values. Sum of all the values, that would be 10. So this solution works, but time complexity is order of n square. So to improve that one, what we can do, if you see, if we try to see the pattern over here, so initially once there is only one sum. So for the second value we just added previous sum plus current value. So 1 plus 2, that is 3, and for this sum we just added all these value this value plus current value. So some I minus 1 plus num size, so that would be 6. And for this one we added like sum plus current value, so that is 6 plus 10. So we can create formula something like this one: running sum I equal to sum I minus 1 plus num size. This way our time complexity will be reduced to order of n. So let's write code for this one. Initial array declaration will be the same. We'll leave it like that, and for the first value we'll write as num0. So running sum0 is num0, because that's like base case. Even if in this case you can directly see I just copied that value from there, and we'll start our loop from 1. Here we can write running sum I equal to running sum I minus 1 plus nums. And now we can just return some running. Okay, so looks like this solution will work. Okay, let's try it against default test cases. Okay, use of undeclared variable, and let's check this one. Size also replace this one, and looks like it's good now. Okay, so against default case it's working. Let's try to submit the solution. So runtime is faster than 38.93 and memory usage is less than 73.74. And this solution has time complexity of order of n and space complexity. Since we are returning one array, so by default we'll have to take like order of n space. So we can count that as space complexity order of n, since we are using one array. And that would be it for the video. I think this solution is pretty good. We cannot improve further. So that would be it for the video. Thanks for watching. Please like the video and subscribe to the channel. Thank you. Bye.